I just realized I didn't have an introduction for this film to explain what we're doing. I'm basically building my Riley Brooklands, and I'm getting ready for building the bonnet when I get some more aluminium, as well as the doors. And the way we do the bonnet hinges on a pre-war car like this is the hinges are kind of integral to the panels. So the one I'm looking at today is the top hinge, and this is my little mock-up. And basically the hinge is made out of pieces like this. These slide down a central rod, and then the bonnet hooks into them effectively like that. So you alternate them as you go along. So you have one with the folded over piece this side, the next one has it this side, so that holds your bonnet all the way down. But from the top, all you see are those sections of hinge piece. No fasteners required, which is really cool, makes it nice and clean. So in the past, I have, about 10 years ago when I did my Austin 7, I made a little jig for folding these up. And now, 10 years later, I've got more experience, I've got more tools, I've got more equipment, so I thought I could probably do a better job. And I came up with a new jig that I'm going to actually manufacture today. This was my 3D mock-up to show how it works. Basically, you start off with a blank piece of steel, and the critical dimensions are the length, the width, and where the first fold is made. So to start, you make a 90-degree fold, and then that goes into the little jig like this. You can do it. You then make a second fold like that. And the idea of this little jig is it'll be made from steel, obviously, and will be clamped in the vise, sort of this way round, with one of the end pieces removable, so you can slide the hinge off. But with it clamped in the vise, it lets you hammer around it. So once you've got it like that, you do a second fold around the first pin, which will get you to there. You then remove it and move it down to the second pin. So we'd have that. Then you can wrap it all the way around the pin and then hammer the edge up 90 degrees like that. Once you've got that far, you remove it from the little jig, and that's when you finish off the rest in the vise with a section of angle iron. You can imagine that kind of clamps it like that. It's a bit hard to see, but when I get this finished, I will do a demonstration of actually using it. Around the angle iron, that'll get these two ends over to 45 degrees, and then you just need a spacer in there, and you can hammer it all the way around. And obviously that spacer is the same thickness as your aluminium, which in this case is 1.6 mil. But that's the idea. So I've got bits of steel out. The first one I made was made from square steel tubing and flat plate, and other bits and pieces. But I'm actually doing it a little bit differently. I've started machining up some high tensile steel. This is going to make the square bars. Obviously, now that I have a mill, I can do things like turn round bar into square bar, and that'll let me make up the thing with the flats. These pins will probably be removable. Because it's held in the vice jaws will hold everything in place. But these square pins are actually going to be probably welded to the plate on one side. On the other side, there'll just be holes so that that top plate comes off, so you can extract the hinge. What I will do is I'll make those two end plates in one piece. So I'll cut two blanks of steel, I'll weld, put a couple of tack welds on two of the ends so I can still grip it in the mill, and I'll be able to drill the holes through for these posts and these bars and have them exactly the same on both plates, and then I can just machine off the welds at the end to get it down to the final dimension, and then that should keep everything perfectly aligned. That's the plan anyway. I've finished all the lathe work now, Oh, it's still a bit warm. And turn down these 2 blanks, which I'm then going to turn into squares. Of course, when you're trying to make a square of a certain size, the round that you start off with has to be bigger. So I worked that out. I just did a simple CAD drawing rather than try and calculate it. So now I should be able to set these up on the mill and mill those square. That's the idea. And then eventually these ends will get machined off so that they sit flush with the plates. I've also made these 3/8 of an inch because I've got a 3/8 reamer. I'm a little worried about my lathe. The 3-jaw chuck on it really isn't very good, and I need to go through and adjust everything because things are moving a little bit, so I'm finding it quite hard to be accurate. The little DRO, magnetic DRO, actually works really well and is easily repeatable enough for the sort of things I'm doing. Obviously something like this isn't critical because it's going to be machined flat, and it's just a jig for folding sheet metal, so I don't need to be precise. But if these were like sliding parts or like piston and cylinder, things like that, I'd really struggle on my little lathe to do it accurately enough with the way it's set up at the moment. This is the first of the milling done to turn these into squares. Oh, I need to, no, it's just a bit of swarf stuck to it, which will be these bits. They'll fit in there. They're about 12mm wide. Again, it's not critical, but I needed to make them the same so that when you pull the metal off one, it'll fit onto the other. So they need to be pretty close, although the metal will always spring back a little bit. So the next thing to do is start thinking about the side plates. So I could either use this little offcut, which is probably enough, easily, and make 2 pieces from this, and then join them together, mill 2 edges, and then I will drill the holes accurately. I can use the DRO to do that, and then I should be able to put it in the mill that way and mill off where I've welded them together, mill them down to final dimension. The reason these sides are flush, this side and this side, is so that when it's in the vise you can hammer it flat and not hit the edges there. While I was milling the little square bars, my postie friend dropped off the brass rod. This is just K&S brass rod. So I got 2 lengths of the 7/16, and they only had 3 of the 3/16. The 3/16 is for the side part of the hinges, and this will be the middle part of the hinge. I think I mentioned in another film that the racing bodies actually had offset hinges, and it was so that you could easily get to the spark plugs, because you can see there, spark plugs are directly under the center line. But since this is more of a touring sort of body, the barrel shaped body, I'll just stick to keeping it straight. It's going to be much easier to make the bonnet. For some reason I struggle with bonnets. There's no shape in them really, it's just curves, but you've got 2 different curves, so it can be quite hard to get them right. And I'm also going to have to decide how I'm going to do the sides and where the sides are going to go to, because of course on this side you've got the exhaust in the way. So this side of the bonnet may only come down just underneath the exhaust, possibly with little cutouts, and there'll be an attached panel at the bottom. Something like that. I'm sort of making that bit up as I go along. Now if I've got the lines of things right, that bonnet should look like it's, yeah, sloping down. Just a bit too much because it's sitting on the body there, not on the edge. But you definitely don't want it going flat and then body. Of course it has to be a straight line because it's a hinge pin. But that looks about right, and it gives a nice fall to it, if you can see it. I'm not sure you can see it. And I have to make the little brackets that it's all going to sit on as well, of course. Now, one thing that did occur to me is I'm just making the hinges the same width, which is 2.5 inches. But will that give me an even number of hinges across here? Or at least close enough. So from there to there is 28 inches. So I'd have to figure it out. So I may need like a little spacer or something in there just to take up the gap, so there is going to be a correct number of these. I could make them a different width, but I've already started based on this width, so that's what we'll go with. And I would have got those measurements off Joss, and Joss, knowing Joss, would have used the right sort of measurements, so I'm going to go with these and assume they're correct. The other thing I did is cut 2 little blocks of steel, and I've welded 2 edges of those together. And that weld doesn't look great, but should be enough to hold it, hopefully. And what I'll do is mill the 2 ends so they're flat, and then I can hold it in the milling vise like that, drill the holes, and then flip it up that way and mill these to dimension. That's the plan. Over on the mill, I've put my little block in the vise, and first I machined off those 2 faces to be parallel, clamped it in the vise, and measured off the offsets for the holes. Again, I did that in my CAD software to get all the right measurements. It's much easier doing it that way, and these should sort of fit in there. Should be fairly flush on the top edge, and then this edge will get machined down to match those, and that's what I can do next. I'm not sure if this hole, I'm using 8mm bar. I've got a lot of scrap bits of steel, and you have to be careful between 5/16 and 8mm. There is a very slight difference, and this hole is drilled just slightly too small at the moment, so I might need to just open those up, or what I'll probably do is machine down the ends of the 8mm just fractionally and make that a nice push fit in one side and a loose fit in the other, so that you can always get one end cap off. I think that'll work. So now mill this side. And I think what I'll do is I'll mill the weld off on this first side, and then get it flat, and then take a measurement so I know exactly how much to take off. This is coming together. I was considering welding this together. It occurred to me afterwards that you don't need to take the end pieces off, as long as you can get the bar out and you don't hammer things around in the wrong order, so you end up locking them to the little jig. The ends can remain fixed. So I've actually used some Loctite 263, which is the red Loctite, which is the never come undone again unless you use heat Loctite. Or when I was at Weta, we used to call it the Roddy use your brain Loctite, after a colleague of mine used it on an animatronic prop once that we had to then take apart, and we struggled to get it apart. So we made sure the bottle was very well labelled after that. But I've actually made it a little bit too good. So because my machining wasn't perfect, it meant I could selectively assemble this so that the steel would fit nicely in that slot. But what that's ended up meaning is I've actually made it a little bit too fat, so you can just get the bar through with a flat piece almost, but there isn't enough clearance between the bar and this. So what I need to do is put it back in the mill and take a fraction of a millimeter off there. I did allow for that, but I only allowed 0.1 of a millimeter, which probably wasn't enough. Should probably be about 0.2. So I'll take 0.1, 0.2 off there and see how that works. I think I have this sorted out now. I just put it back in the mill and just took a little bit off that face there. Oh, I've already dinged it. So the way this works is you have your blank piece of metal, and that has to be a really nice 90-degree bend, and it needs to be very flat across here where this rod goes through. So I dressed it up on my little block. That fits in there. Obviously it would be full width, but I'm just testing at the moment to get the lengths right. That pushes through like that, and then you can form the loop. By using thin strips like this, I can do it by hand. But, and then getting this out can be a little bit tricky, so you either pull it out or else knock it out with a brass drift, which I've got here. So now you end up with a shape like that, and you move it over to the second position. Oops, it's a little bit fiddly. Like that, and you turn this around in the vise. So I found by leaving the shaft longer, you can quickly rotate it. It pivots on it. So like that. And then you knock down this corner. It's a bit hard with one hand. Normally you'd be doing this a bit more carefully to make sure it's all very tight, and then you can knock around the piece like that. Like I said, it's tricky with one hand, but you get the idea. And that basically gets you to that stage. And then it's just a simple matter of folding those two ends around a little spacer. And I haven't made the spacer yet. So the way that works, this is where the little piece of angle iron will come into it, which it helps to put the bar back through the hole just to stop that collapsing up. And then your little flat spacer goes in there, and then you can clamp that in the vise like that, and that lets you get that past 90 degrees. Once it's past 90 degrees, it's pretty easy to then hammer it over by hand. And that's pretty much how that should work. Like I say, it's a little bit tricky. I do notice that on my originals, I've got a much flatter base there, and it may just be because I haven't actually done the put the little piece in there yet. I think once that's in there, this will flatten out a bit, but that should work fine. And I did have to machine one end of these bars, but then that'll fit on the bonnet like that. So I think that's going to work. I just need to make the little piece that holds it, goes in there as the spacer. And my tolerances were too tight. I did have to loosen things up a little bit, but it doesn't really matter. So that bar fits through there. I ran a 8mm reamer through both sides to get that to work. But I think that red Loctite should hold that fine, especially because it's been clamped in the vise like that. So really it's just there to stop these turning. I was considering welding it, but I was worried it would distort things. So, And I also had a problem with, I couldn't get the bar to go through, and I couldn't figure out why. And it was because there was a very slight burr on there. I just had to sort of file off and then sand smooth. But yeah, it's come out reasonably well. I might just wire brush the outside of it, and I'll probably put it through some gun blue just to give it a little bit of corrosion protection. I think it needs something, but I'm thinking that's going to work. A few little tweaks, and I think I can show how this works now. So it sits in the vise like that. It's a little 8mm bar, and you start with the blank with the corner folded up 90 degrees. I'm just using thin strips because it's easier to do by hand. You do have to make sure that it's very flat here, because this goes in there like that. Nice. This pin has to go over the top of it, so that's where I had to mill off a little bit just to get that to go through. And if this isn't completely flat, it can be quite hard to push this pin all the way through. Dress it on this a bit. So then once the pin is through, you can then hammer this round. I can do it by hand because it's so thin, to there. And that makes the loop that goes around the hinge pin. Then you can take this out, which can sometimes be a bit tricky. So either punch it out with a brass drift or pull it out with the Knipex. And then it's a little bit tricky with one hand, but then it fits in there like that. And now what you can do is loosen the vise. Since the shaft is longer, it won't drop down. Clamp it up there, and now what you need to do is knock this one over. So it's a bit tricky with one hand, but you get the idea. So that goes over like that, and then you can fold the next one over the top of it. Like that. Then you take this out, and this is where this little piece of angle iron comes into it now. So I can put that in the vise, and to get these folds nice and tight, put that in there like that. Tricky with one hand though. So that goes in like that. This will go a bit loopy for a second. Then I can tighten that up and hammer this. Get that nice and tight, and then pull this out again. And now you can see why the pin has to be removable. And then that basically gets you to that stage. And then what I need to do next is make the little piece of steel that is the right thickness. It needs to be about 2mm, 1.6, 1.8, something like that. That fits in there. And then you put that in there, and then you put this back in the vise like that to start hammering those around. Once you've got those past 90 degrees, it's then dead easy to fold them the rest of the way, especially if you, it's best to keep the little bar in there because things will tighten up a little bit. And then that basically gets you to that stage. So I think I've still got the piece of, I think it was galvanized sheet that fitted in there, and that was the perfect size to match the thickness of the aluminium I'm using. But yeah, that's how that works. Obviously you want it a bit neater than that, and this is why the dimension of that fold is critical, because you want this to fold back but leave that gap, because you need that gap there for this folded edge to fit into. So that's what I'll do with these test strips, is figure out what the exact measurements are so that all fits together nicely. But yeah, it's come out reasonably well, and a bit better, a bit easier to use than the last one, which had multiple pieces and was a little bit fiddlier. But that was basically how it worked. I made that last one by hand and it worked perfectly. This one I tried to machine and I had to keep adjusting it to make it work, but it seems to work now. It'll be interesting to see if that Loctite holds up to the hammering. I think it will. It's very strong stuff. But yeah, I think that's come out quite well. I'm going to give this a wire brush, and I think I'm going to put some gun bluing on it, just to help stop it rusting, basically. That's interesting, that now doesn't fit very well. I might need to sand just a little bit off the edges of that so that that fits in there nicely. That's in the back there, that's why. So that does fit. So that's how that works. I went through my scrap bin and found what I'm pretty sure is the original piece of scrap steel I used to make it the first time. A piece of 2mm thick galvanized plate. I remember it was a lot bigger than that before though, and I just made a little strip, and basically that goes in there like that, and the little angle piece clamps like this, so that when you clamp it in the vise you can hammer this down, and then you just hammer it all the way around that little strip. The first test I did, I had it a little too wide, so it's not quite flat. But you can see once you do that hammering how the hinge flattens out. So you end up more with the shape of the original. Sort of makes the bottom of it all nice and flat. And tomorrow it'll just be a matter of cutting some test strips so I can remember what the measurements are, get the right measurements to get the correct gaps and things. But it's come out nicely. I did gun blue it, and then I've rubbed it all down in ACF 50, just oiled it with that. Hopefully that stops it rusting. That can all just live in there. Like I say, tomorrow I will try doing some proper size ones, but I really need to get some 1mm thick galvanized steel, preferably cut into strips on the guillotine, because it makes them nice and even. So I'll have to see if I can figure out some way of getting that done. Oh yeah, I think that was a good effort for today, and my hands are feeling much better now as well, apart from all the little steel splinters. It's a lovely day today, and I've been practicing a bit more with my hinge maker. There's a whole bunch of little test pieces I did to get the measurements correct, and I now know what sort of measurements I need to make this work. It's about 15/16 on the fold up and 3 1/4 inches long total. And I've decided to make the hinges 2 inches long because, one, I think it'll look better on the car, and two, ideally I should have made this longer because it's made for 2.5 inches, but what I've found is you really need to be able to get in here with a hammer just to tap this down. If I was making this again, I'd put a bit more of a radius on that middle corner to allow for the corner on the steel. I was able to open that up with a piece of sandpaper, but it'd be easier to sort of make it again. But this is how this works. You put the 90-degree fold down in there, you put the bar through. By hand, you just wrap this around, This is 1mm steel I'm using, but that's not what I'm going to make the hinges from. I'll make them from 1mm galvanized. So once you've got that wrapped around, you can pull the bar out. It's usually a bit tight at this point, so yank it out. Then you end up with that shape. You move it over to the second hole. Put the bar through. Turn this around in the vise a little bit, like that. And then I move the camera a little bit. Let's see. So now by pushing on this, you can keep this edge flat and you can break it around that corner. You don't have to hit it too hard, you just need to bend it. And you do this bit by hand, like that. And then you wrap this piece around. You see what I mean about needing room to hammer around the jig. I've already hammered the corners a couple of times. So now we can take this out without knocking the camera over. Pin pulls out and you've ended up with that sort of shape. Put the pin back in. These are a little 2mm strip. Goes in there. And then the little piece of angle. Clamp that tightly in the vise like that. And then start tapping that round. So we now have that. And then what I've found works well now is if we take this over to the mill, I can put it in the milling vise. You have to have hammered it enough of the way round for it to start going. There we go. Just sort of clamp it round. Like that. That pin should be fairly loose in there. This may need a little bit of tightening up. Oops. The milling vise is good for this because it's got very flat jaws. And take it back over here. Normally this is a little bit stuck. This comes out easily. But if you just tap it with a hammer, and you end up with a little hinge. That goes on there nicely. And it should also slide on there, like that. So these are some of the ones I've made earlier on. This is what I mean about the hinges alternating. They basically work like that. So you've got the second half of the bonnet hanging off the alternates. It hinges like that. Looks quite neat from the inside. When I'm doing them properly, I take a little bit more care with my hammering and try to get these a bit flatter on the back and things like that. But that pretty much shows how that works. So now I need to get more material. I need to get the galvanized metal. I'm a little bit worried that it'll be slightly thicker and it won't fit in my little jig. So I may end up making another one. It also occurred to me that I didn't need to turn all of this down. I could have just milled that. I didn't need to bother spending the time turning all that middle section down. That Loctite is holding up really well so far. So I think that'll work for making a bunch of these 2-inch hinges. I think I need about 14 of them, 12, 14, possibly 13 by the time you've got the little end pieces. And I may possibly add another 1/16 of an inch to that outer one just to get those to line up, but it doesn't really matter because once it's in there, like that, you can't see it. So I think that's close enough. And of course, if you need to, you can tighten this up so those hinges won't move. You don't really need any fasteners, they're not going to come off. That's what that'll look like.